OK, so we are halfway done. We have successfully gotten this printf function to write to the address deadbeef, because when printf sees this %n, the next unused argument on the stack is arg4. And it just so happens that I put the address deadbeef at the memory box corresponding to arg4. The next thing that needs to be true is I need to get that target number into memory, the number 100. And remember, the way that you control the number written into memory, whether it's 100 or 50 or 200, the way that I control that number that I write into memory is by controlling the number of bytes printed so far. Because what does %n do? It writes the number of bytes printed so far into memory. So specifically, I need it so that by the time this %n occurs, 100 bytes have been printed in total. So let's do some counting. What does printf do? It prints the EF, that's 1 byte. Then it prints BE, that's another byte. Then it prints AD, that's 3 bytes. Then it prints DE. So by printing out this value deadbeef, 4 bytes get printed in total. OK, well, that's good. That's not 100, though. If I stop there, I would get the number 4 written into memory, and that's not what I want. So I'm actually going to use a little trick here, because I want to get to 100 characters. So I could just try writing 96 A's and be done with it, but that's not going to fit in my buffer. I can't fit 96 A's in there. So I'll use a little trick. In printf, if you add a number before the formatter, you're telling printf to pad. So if I say something like %94C, I'm telling printf, go on the stack, take the next thing on the stack, and print it. But when you print it, please pad it to 94 characters. So add extra space characters so that the total number of bytes printed is 94. So that's a nice little hack that's going to allow us to print out 94 characters without writing 94 A's, because that would have been very annoying and also would not have fit in buffer. So this %94C, to make a long story short, it prints out 94 characters. It goes on the stack, takes the next unused argument, prints it out, and if it's not 94 characters, it will add extra spaces until it's 94 characters. So how many characters have we printed so far? We printed 4 from deadbeef, and when we saw this %c, we substituted it with something on the stack, padded it to 94, and we printed another 94 for a grand total of 98. So we've printed 98 characters so far. The next % formatter is %c. So I go on the stack, I take the next argument, and I print it out. And I guess I haven't told you this so far, but C stands for character. So it takes up 1 byte. So when I take %c and I print it out, prints out 1 more byte. I am now at 99 bytes printed. And there's another %c. So I go on the stack, take the next unused argument, which happens to be this one, print it out like a character, which takes up 1 byte. And now I am at the magic number of 100. And just so happens the next input is %n. So when %n thinks how many bytes have been printed so far, well, the answer is 100. And so at this point, when I see the %n, I will write the number 100 into memory. So that was the last piece of juggling I had to do. And notice that all of this had to happen at the same time, which is where the trickiness of this exploit comes in. I had to simultaneously think about each of these % matching up with someone on the stack, and %n had to match up with the deadbeef. That's how I control where I am writing. But also, I had to make sure that the total number of bytes printed, thanks to this padding formatter, that had to add it up to 100. And that was controlling what I write, the number that I write. But if everything lines up correctly, I should get the case where when I hit the %n, I look up the next unused argument, it happens to be deadbeef. I count the number of bytes printed so far, happens to be 100. So this exploit is going to write the target number 100 to the address deadbeef. And we are finally done. One very small nit that sometimes people ask about, the %c formatter is kind of weird. When it goes on the stack, it does read 4 bytes, but it prints it out as a 1 byte character. So it ignores the top 3 bytes. Kind of a weird quirk of how C works, but in case you're wondering why it looks like this, all the arguments, %c, %n, whatever, they all consume 4 bytes on the stack. They match up with one of these memory boxes, even though some of them only print one of the characters. Kind of weird, but that's what it does. Not the most important thing here, but something people ask about.